Hi, so here's the last bit of the lecture. Let me just make this slightly larger so you can follow. That's perhaps slightly too large. So in class I finalized the lecture, or I ended the lecture by talking about a sample write-up. Perhaps I rushed through it, but basically you would describe the table and you would mention whether there's significant effects of variables. You would then report the likelihood ratio tests, which you can get from the pseudo R-square command from Nagel-Kerke, which you saw, but also from the likelihood ratio tests. They correspond to the deviance value, but you can also check the R-companion output. You would then describe the odds ratios or illustrate the effect also. And you can do that graphically, for example. Now I'm going to talk to you a little bit more about one way of illustrating it graphically for categorical packages, which is via the VCD package. If it's continuous, you can plot the odds ratios and their 95% confidence intervals. You can have an example of how to do that here. So just have a look on this blog. Just we'll walk you through it, and it can show you some corresponding odds ratios for groups. You might want to then divide it into people who are high and low, for example. So, but for a categorical variables, we would use mosaic plots, and you can also look at some alternatives like GG mosaic. But today I'll just focus on the VCD package. So how to do it? First, we have to make some categorical variables, and it's important to note that the previous version of the slides had this wrong. I've now corrected this, so pay attention and use the latest slide. So before it had yes and no, but we use the cut command to create a categorical variable because the Puma data unfortunately doesn't have any categorical variables. So we make a variable which is called obese, which cuts it at 30. And then we make a variable to distinguish never pregnant women from ever pregnant women. And I've put the cut here at 0.199, which is just below 1. And this is how you would create those categorical variables. Now I've already loaded the VCD package. You might want to reload it with file acquire or library. I then use our color brewer to again help us pick some colors. You will likely get an error because we're only going to fill in some type of cases. We use colors to generate some colors for us. The fill colors. Oh, and here I've actually add the require VCD command. You could also move it to the top. And then we plot a mosaic plot, and these are the commands. We use the tilde for our key variables. Then we list them: diabetes, nulla gravata, obese. We don't want any zeros to be listed, so that's why we have this command. We tell R where to look for the data, and then we sort of tell it how to fill up the colors, and we use these commands to do that. We don't want the legend, and we can ask it to label it with the actual values, which we have, and then you get something. You should get something nice looking like this. And basically, the area will sort of tell you what's going on. So, for example, you can see that there's fewer people who are never pregnant in our sample, and you can also look at the distribution in terms of negative, positive, and the numbers sort of tell you the spread of the cases. So perhaps this is quite useful. You might want to toy around whether you have diabetes on this axis or not axis, but it sort of gives you the division of the data. Now, in terms of exercise, that's all I had to cover. So I would like you to use last week's salary data. If necessary, you have to calculate monthly salary again. I would like you to calculate the Spearman and Pearson correlation between years since PhD and monthly salary. Conduct the significance tests on those. Pick one of those, either pick Spearman or pick Pearson, and discuss the outcome. Then I would like you to build a hierarchical regression model, as we've done in class. Use multiple steps in every single step. Add the variables while keeping the previous variables. So step 1, step 2, step 3. I would like you to export a hierarchical regression table, as I've demonstrated in lecture. For this final model, you would test the assumptions, and you would discuss how you would combat those issues if they exist. Then I would like you to calculate the standardized coefficients for Model 1. I would like you to interpret this coefficient. I would like you to bootstrap this coefficient and report it as you would do in a paper. I would then also like you to make a model prediction based on this. Now the next bit we move to a new data set. We move to the cont'd package. I would like you to load the German credit data set. You can find out more about it by clicking on this link. It contains data on credit scores for 1,000 cases and has 62 different variables. As done before, you might want to explore descriptive statistics, so think back to skim-R. I would like you to make a correlation plot for up to 10 continuous variables. You can also use some of the dichotomous variables because they will be coded as 0, 1. I would like you to export a correlation matrix of up to 10 of those variables. You can pick any ones you like. Then I would like you to conduct a hierarchical logistic regression on a class, which is basically whether individuals have good or bad credit. And each step, as before, keep the previous variables. You can add step 1, step 2, step 3, and step 4. I would like to that you export a table with your key results. So use a Stargazer, or perhaps you also want to use dplyr and Broom to help you. Choose some categorical variables and make a beautiful mosaic plot, as I've shown you in the last bit, with credit class as a dependent. I would like you to calculate all the odds ratios for the final model, for Model 4. I would like you to calculate the odds ratio for a shift of 1,000 D-Mark. Yes, it's a Deutsche Mark because this is from before the euro, and in credit status for Model 2. And I would like you, if you have time, to make a mosaic plot via GG Mosaic. I would like you to have a look at ROC curves and find out what they're all about and have a look. But those are extras. So here are some references. You can also find references on the reading list. So I spent some time reading through all these resources. You have, again, lots of great resources. I can highly recommend the Crawley book, the Fox book, and there's some which aren't even listed here. For example, the book by Andy Field, which also deals with correlation, regression, and logistic regression. That's it for now. Best of luck. See you next week.